Alright, so today we're doing perimeter and area, which you've done in Year 8 before. But today we're just going to start off with the basics from Year 8 and then we're going to build on them. So we're not mucking around with too many of the easier questions. Alright, so perimeter is the total length around the outside of a shape. You should know that already. Any sloping sides that you need to find are probably going to be the hypotenuse of a right-angled triangle. Okay, so you'll probably be using Pythagoras' theorem to be able to get that sloping side. Sometimes it might be a vertical side or a horizontal side that's missing, and again, you'll still be using Pythagoras' theorem. So it's not always with the sloping sides. Okay, so make sure you're able to find all the different sides that you need for the complicated shapes and then total up all your sides. Okay, so for area, you all should know by now it's the space inside a closed figure. So with composite shapes, when we have more than one shape together, you might be adding or subtracting areas depending on the question. Alright, so we're going through the basics of all the area formulas. You need to write all these notes down and make sure you know the basics before we get into anything harder. So we have a square. You know a square has 4 equal sides, but it also has at least one right angle. So if you've got 4 equal sides and they mark one right angle, that's enough to tell you that the rest of the angles are also going to be right angles. The area formula for a square is area equals side squared. So area equals s squared, and s is the side length of the square. The rectangle, area equals length times breadth. That's pretty easy. You should know that one. 3, the triangle. The formula is area equals a half BH. If you want to write it differently because you've learnt it differently before, like BH over 2 or something, that's fine. With your triangle, you can have all sorts of different triangles as long as you have a base and a perpendicular height. Okay, so in this first one, it's easy because you've got your base, there's your right angle, and the perpendicular height has to come off the base at right angles. In this one here, we have our base, and here's your right angle. So your perpendicular height is coming off your base at right angles to reach that third point up there. Okay, this one's a little bit more complicated, but it's the same idea. We have a base, and then if you extend that base a little bit, you will create the right angle that you need for a perpendicular height to reach that other point. Okay, so it's like if you're in a plane and the pilot tells you the altitude, he's telling you the perpendicular height. So here's the plane. He might be over the Pacific Ocean, but this is his runway. Here he is. He's flying at a certain altitude or a certain perpendicular height, which means if you drop straight from there, straight down below, might be over the Pacific Ocean, it doesn't matter. That is what he's telling you. Okay, so sometimes you won't see the right angle inside the triangle. You'll have to extend, or in later years we call it produce, that side to be able to see that right angle. Okay, so remember that h is always a perpendicular height in all our formulas. Okay, so looking a bit further over, we're looking at the parallelogram. So a parallelogram is like a pushed over rectangle. So if you start off with a rectangle and you just slide it to the side or the other side, you're creating a parallelogram. So it still has opposite sides equal and parallel. These ones are opposite sides being equal and parallel. Okay, what it doesn't have are the right angles that a rectangle has because you've pushed it to the side. So the formula is very similar to the area of a rectangle. In a rectangle we do length times breadth. Here we do base times height. So 2 things are being multiplied together. Don't forget the h is the perpendicular height. So if this is your base, h has to come off the base at right angles to reach the other side. So they can write that in there. They might write it out here. Sometimes they do that. Might be written there. Might be written in the middle here. As long as there's a right angle attaching it to the base, or in this case written out there, you've got the idea that it's the perpendicular height. There's all sorts of ways they can do that. All right, now the trapezium has one pair of parallel sides. There they are. A and B are the parallel side lengths. H is the perpendicular height between those parallel sides. So look for the right angle, and that's your perpendicular height. Okay, so your formula, don't mess this one up. Area equals a half H bracket A plus B bracket. A and B are your parallel sides. I always put those in first, and then I go in and fill in this space later once I know where the parallel sides are. Because they may be facing the other way, all right? You might have your parallel sides like this, sideways, all right? So then you've got to look that way to see the perpendicular height. All right, and one more formula to do, but it's two more shapes. Okay, so in this next one, sorry, I'll just move this over a bit so it's a bit closer for you. All right, so in this next one, we're looking at a rhombus or a kite. So a rhombus has 4 equal sides. It is a pushed over square. So a square has 4 equal sides, and if you push it to the side, either way, you're going to create a rhombus. It still has the 4 equal sides, it just doesn't have the right angles anymore. And a kite looks like a kite flying in the sky. So it's got 2 equal sides next to each other. We call that one pair of adjacent sides that are equal. Adjacent means next to. And it's got another pair of adjacent sides equal. So it's got 2 pairs of adjacent sides that are equal. But it looks like a kite that flies in the sky. Now this formula is area equals a half xy. X and y are the diagonal lengths. It doesn't matter what the side lengths are. We are looking at the 2 diagonals in both of these. And it's the full diagonal. Okay, so it's this whole length. That's one diagonal. This whole length, that's another diagonal. And in the kite, there's one diagonal, the whole length, and this whole thing is your other diagonal. So I'm going to come back in the next video and we'll do lots of examples on this work.